Welcome to Powertech Insights, where learning empowers you. Today, we're diving deep into one of the most essential tools in electronics, the multimeter. Whether you're a beginner or an experienced technician, mastering the multimeter is crucial. Let's get started. A multimeter is a versatile tool used to measure voltage, current, resistance, continuity, and more. It helps in diagnosing electrical issues, testing components, and ensuring safe connections. There are many brands of multimeters available on the market, ranging from budget-friendly models to high-end professional tools. As you can see, I also have my own multimeter here, but today we'll be using one of the most popular and reliable models, the Fluke 117. Fluke is known for its durability, accuracy, and safety features, making it a top choice among electricians and engineers worldwide. Let's dive in and explore all its functions along with essential safety tips. Before using a multimeter, always follow these safety precautions. Inspect the multimeter. Check for any damage or broken test leads. Use insulated probes. Always handle probes by their insulated parts. Choose the correct setting. Setting the wrong function can damage the multimeter or cause accidents. One-hand rule. When measuring high voltage, use one hand and keep the other away from any conductive surface. This reduces the risk of electric shock. Safety first, always. Continuity testing. Let's start with continuity testing, used to check if a circuit is complete. Step 1. Turn the dial to the continuity setting, usually represented by a sound wave or diode symbol. Step 2. Touch the probes together. If the multimeter beeps, it means the probes are connected. This confirms the multimeter is working properly. Step 3. Place the probes at both ends of the wire or connection you're testing. A beep indicates a complete circuit, while silence means an open or broken circuit. Safety tip. Always ensure the circuit is powered off before performing continuity checks to avoid damage to the multimeter. Measuring resistance. Next up is resistance measurement, which checks how much a component resists current flow. Step 1. Turn off power to the circuit. Step 2. Set the multimeter to the resistance setting. Step 3. Place the probes on either side of the resistor. The display will show the resistance value. Safety tip. Always discharge capacitors in the circuit before measuring resistance to avoid inaccurate readings or damage. Measuring AC voltage. Now, let's measure AC voltage, commonly used for checking power outlets. Step 1. Turn the dial to the AC voltage setting. Step 2. Insert the probes into the power outlet. Step 3. Read the voltage on the display. Ensure it matches your region's standard voltage. There are many socket testers available on the market that make this process safer and more convenient. These testers simply plug into the outlet and can instantly indicate if the wiring is correct, if there are any faults, and some even display the voltage. Using a socket tester is highly recommended, especially for non-professionals, as it reduces the risk of electric shock and ensures safe operation. It's a quick and reliable way to check outlet safety without handling probes directly. Safety tip. Always be extremely cautious when working with high voltage. Use one hand only and keep the other away from any conductive surface to minimize shock risk. Measuring DC voltage. To measure DC voltage, like from batteries or power supplies. Step 1. Set the multimeter to DC voltage. Step 2. Connect the red probe to the positive terminal and the black probe to the negative terminal. Step 3. The screen will display the voltage. If the reading is negative, switch the probes. Safety tip. Start with the highest range if you're unsure of the expected voltage. Measuring DC current. To measure DC current, Step 1. Move the red probe to the appropriate current port. Step 2. Turn the dial to the DC current setting. Step 3. Disconnect the circuit and insert the multimeter in series with the load. Step 4. Power on the circuit and read the current value. Safety tip. Make sure the expected current is within the multimeter's limit to avoid blowing a fuse. Testing diodes. Diode testing checks if a diode conducts in one direction. Step 1. Select the diode test mode. Step 2. Place the red probe on the anode and the black probe on the cathode. Step 3. A forward voltage drop should be displayed. Reversing the probe should show no reading. Safety tip. Ensure the circuit is powered off before testing diodes. Measuring capacitance. To measure capacitance, Step 1. Turn off power to the circuit and discharge the capacitor to avoid damaging the multimeter. You can discharge it by connecting a resistor across its terminals. Step 2. Set the multimeter to the capacitance mode, usually represented by symbol. Step 3. Disconnect the capacitor from the circuit for accurate measurement. Step 4. Connect the red probe to the positive terminal and the black probe to the negative terminal of the capacitor. Step 5. Read the capacitance value on the display. Compare it to the capacitor's rated value to check if it's functioning correctly. Safety tip. Always ensure the capacitor is fully discharged before testing. High voltage capacitors can retain charge even after the power is off, posing a shock hazard. Measuring frequency. To measure frequency, Step 1. Turn the dial to the frequency setting, often marked as hertz. On the Fluke 117, this function shares the same position as the AC voltage setting. Step 2. Connect the probes to the points where you want to measure the frequency. For example, across the output of an AC power source or a signal generator. Step 3. Read the frequency on the display, which is typically shown in hertz. Step 4. Compare the measured frequency with the expected value to ensure the circuit is operating correctly. Safety tip. When measuring frequency on high-voltage circuits, maintain safe probe handling and use one hand to minimize the risk of electric shock. Non-contact voltage testing. Power on the meter. Turn on your Fluke 117 by pressing the power button. Enable non-contact voltage detection. There is a special volt alert sensor located at the top of the meter. Turn the dial to volt alert. Approach the target wire or outlet. Bring the top of the meter close to the wire, outlet, or electrical component. The sensor will detect an AC voltage presence without physical contact. Observe the indications. If voltage is present, the meter will beep and flash a red light. If no voltage is detected, no beeping or flashing. Remember these key safety tips. Always check the multimeter and probes before use. Select the correct setting and range. Handle probes by their insulated parts. Mastering these functions and safety practices makes troubleshooting and testing safe and effective. Thanks for watching. If you found this guide helpful, make sure to like, subscribe, and hit the notification bell for more insightful tutorials. Drop your questions or suggestions in the comments below. Stay safe, keep learning, and see you next time on Powertech Insights.